In this example, I want to talk about the use of AMDIS. Primarily, AMDIS excels at two things over our NIST SI function. One is going to be if we have very low signal to noise. In this data file, I actually have very good signal height, so that's not of concern. But the second thing AMDIS excels at is something called co-elution, where two different chemical peaks or two different chemicals are coming out under the same peak. Here, if I zoom into this peak at about 1.5 minutes, you'll notice that on the left-hand side, I'm making an identification for benzene with a 78 mass fragment. I'm going to go ahead and plot that up here. But on the right-hand side of this peak, I have a different identification with a lower SI carbon tetrachloride. So what I can do is load this into AMDIS and get a better hit comparatively, about 700. It should be higher if I load it into AMDIS. So let's go ahead and click our AMDIS button up here on the top-hand toolbar. Once that runs, I'm going to find that same peak. It came out at about 1.5 minutes, right there with benzene. We have carbon tetrachloride. So I would think that I'm confirming that ID because I have this net match of 99, which is very, very, very high. This purity score over here is fairly low, but that's only telling me that it's low because it's co-eluting. It doesn't lower how sure it is that it's the correct answer. But there's an additional problem with AMDIS. AMDIS is only able to identify the chemicals that are in its specific library. In this data file, I'm searching for things in the HAPSITE.msl library. Let's try and change that. I can go here to Analyze, and then over to Target Library, and I can view all the possible identifications AMDIS can make with this HAPSITE library loaded. But let's say our secondary identification, down here we had a possible trichloronitromethane where we were looking back in NIST. If I switch that by going to Select New and then CW, I'm actually going to get a different identification here. Now it's telling me that same peak is trichloronitromethane with an equally or an almost equally as high net match of 96. So I can't choose one over the other. They have similar SIs, they have similar net matches. And you really want to figure this one out because carbon tetrachloride is a carcinogen that's particularly dangerous to your liver, whereas trichloronitromethane is an explosive precursor. So very different sort of results or situations depending which identification you have. If you want a better idea of how to clear up this identification, you can see my video on retention indexes.